Cool. Great. Just a few words. So we have today our last second guest lecture, and I think last meeting within our course of data analysis in Hill Academy, which is now, of course, is much broader. For a broader audience. And today we are happy to have Iza Romanovska, who is Associate Professor at Aarhus University, author of numerous works on agent-based modeling, on complexity science, and in case someone is clueless about what are agents, what is models, I think Iza is one of the best people in the world that could explain you this. So I'm thrilled, and I'm stopping at that, and think we can start.
Oh, Alisa, thank you so much. This is such a lovely introduction. Thank you so much for this. All right, before we even start, I just want to say thanks you so much for finding the time and giving me this opportunity and this space to talk about my work, but predominantly about the technique. And I feel like, you know, this is a really special occasion because, you know, there are certain things in archaeology that allow us to actually turn our work into something that has relevance to what is happening around us. And, you know, we all know that we're, you know, at the brink of a gigantic human catastrophe in all aspects. And we see this catastrophe in everywhere around us, which obviously you are acutely aware of. And I do believe that archaeology has a role in it. It's not just a study of the past, but it's actually a study of humans and how they deal with crisis. And I believe that is a very relevant topic for all of us. So I hope today's today's talk will be of interest. And I divided it into a bit of, you know, me talking. Feel free to interrupt at any point and ask questions. And then also a practical side of things, because I've taught agent-based modeling, a simulation technique, which involves quite heavy computational skills to many people. And it turns out that most archaeologists are more afraid than they should be. It turns out that most archaeologists are like, oh, I can never code. Oh, this is for the smart people that are in the technology department. And then they sit down and they say like, oh, is that really it? Really? Like, oh, I just write those words and then it works. And they're like, oh, if only I had known before, I could have done it. Like, this is clearly within my ability. So I believe every single one of you can do it if that's what is necessary for your research. Okay, so without any further ado, I will now prove that I can operate Teams at least a little bit. There we go. And if you can tell me verbally, not by waving, whether you can see my presentation.
Yes, I see it at least.
Perfect. If there's any question or if I have to stop or slow down or anything like that, you do have to tell me again verbally, because I cannot see your faces. I'm basically talking into my presentation. All right, so let's start. Agent-based modeling. I want to start with this setting of what is it that we're actually talking about. And I always use this example from a really great book, The Model Thinker by Scott Page, who's an economist and tries to teach people model thinking. So what is a model? What is data? What is information? How do we actually know what we know about the past? And the way to read this picture is you go from the bottom and you go up. And this, in a way, reflects the scientific process of how we gather information, how we gather evidence, and how we then based our understanding of how the world works now or worked in the future based on that. So at the very bottom, we've got data, right? And data, you know, you're all familiar with. It's as pieces of pot, it's lithics, it's location of settlements in the past. It's any It's any record of what has happened in the past that we have, any information of any sort. And that data can be structured. So for example, we can have an Excel file which has a latitude and longitude of every site, Neolithic site in, say, Western Ukraine, or it can be unstructured data. Our classical archaeologist friends, they are the masters of unstructured data, where they kind of know certain things. So, Plato said this about that, and then we know from this source, historical source, something else. So that's also data. That's also a record of how the past was, but it's less structured. We never stop at this level. Like, you never take your Excel sheet with your longitude and latitude of size, and you don't actually just squint at it and say, okay, so this is the knowledge, right? Like, you always do something with it. What you always do with it is summarize it. So in case of those locations of sites, you would put it on a map, right? And probably on this map, you'll also have other information, for example, where the rivers were, or, what is the height above the sea level, or what kind of soils are around. If it's pottery sherds that you have recorded in your spreadsheet, then again, you don't just kind of squint at it and say, okay, this is what the past was, but you find, for example, the average size of a vessel for a given period or a given type, or you count them. So you say, okay, so we have 350 amphoras and 272 cooking pots, right? So we always summarize this data, and that's what we call information. So information is where I can say there have been more Neolithic sites in the west of Ukraine during Neolithic than in the east of Ukraine. That's information. Or I can say on this site, we have more cooking pots than amphoras, or amphoras in general are larger than cooking pots. So that's information that is based on the data. Could I have that information without the data? Well, no. I mean, if I have not collected pottery sherds, then I do not know that there are more amphoras than cooking pots on a given site. But again, I mean, that's an interesting information. That's great. So now we know there are more amphoras than cooking pots, and amphoras in general are bigger than cooking pots. And the question is, so what, right? I mean, who cares? Who cares? Okay, so amphoras are bigger than cooking pots. I mean, we're not exactly going to the major news outlets saying, science, we've just discovered this. What we're more interested in is the level of knowledge. So that's, again, the next step in the process, because we ask, so what does it mean? What does it mean that there are more amphoras than cooking pots, right? Usually we would interpret it verbally. So we would create some kind of model of the world where we say, you know what? If there are more amphoras than cooking pots, that means that the activities in the past related to the amphoras have been more common on this site than activities related to cooking pots. Amphoras are used to transport goods. That means, in my head, in my model of the world of the past, that there was more trade involved, like more activities related to trade on this site than cooking activities, right? And that's knowledge, right? This is a level of knowledge. And this is usually the level at which we kind of stop in archaeology. And that's all right. But there's one more level higher up, a level of wisdom. And a level of wisdom is more of a level where we find generalities about humans and human societies that allow us to kind of speak through universalities. And by universalities, I mean things that apply to most human communities. So for example, if I analyzed all of Roman sites across the Mediterranean and then compare them with all the Chinese archaeological sites and maybe all of the Maya sites, then I could start saying, you know what, in general, sites that have more vessels related to trading are found on coasts rather than inside, in the, like, deeper in the land. Whereas sites that are more inland have more cooking vessels. That may mean that trade very often goes through the sea route, right? And that would apply universally, whether through the Roman Empire or other places. To do that, that means we need to collect a lot of data, summarize it to get the information, create a model of the reality in the past where we say, okay, amphoras are related to trade. Therefore, there was more trade activity if there are more amphoras. You know, you can already imagine there are quite a few problems with that. And then derive those general truths at the very end. But it's a worthwhile process. It's worthwhile going all the way up. All right, so let's start. You know, we're going to be talking about this level, knowledge. Let's start with a definition. So what is a model? I very often use an example of a map, which is a model that we're all very familiar with. And this is a map of Aarhus. This is a town where I live. I'm currently where the red dot is here. This is the university campus. And this map shows me certain things about the city of Aarhus. It shows that it's on the coast. That's true. It shows that that there's a ring road. You see this yellow thing here? Yep, that's the ring road. It also shows me how quickly I can get to this restaurant in the south of the town. 13 minutes if I cycle. But it also shows certain things that are actually not true or are gross simplifications. So Aarhus is not gray, right? Like this color is wrong. Like Aarhus has all sorts of colors, but it's not that the whole place is gray. And the center is not yellow. There's also no letters hanging above my head that says Aarhus Domkirke or Aarhus street food. That doesn't exist. Those are just markers on this map that are put there for my convenience, but they don't represent anything real, right? Like we don't have those kind of little symbols in the city. And, you know, what is depicted on this map is also interesting. So you can see the streets, you can see the green areas, you can see the sea, and you can see the yellow bit, which indicates the interesting part of the city, which also is quite an interpretation. But it doesn't show, for example, individual trees or the geology underneath. Or it doesn't show the areas where richer people live versus poorer people, right? So this map depicts certain things, but not others. Weirdly enough, what you're looking at is also a map of the city of Aarhus. This map depicts our very elaborate, as you can see, this is a small place, tram system. And this map depicts Aarhus in kind of, you know, one dimension, right? Because it's just a line. Weirdly enough, this also shows me how to get from where I am to this restaurant. All I have to know is that I need to go from Universitetel here to Aarhus H. So this is the main train station, and from there I would have to walk. So you can see that that one place, Aarhus, can have multiple maps that depict it. And there isn't the right or wrong way of creating a model of the city. Whether the representation of the city is correct or not depends on what is it that I want to do. If I want to cycle, then this map that you see here is better. If I want to take the tram, then this is useless. This is actually a much better map of Aarhus. So a model is basically an abstract, simplified representation of the world. And because it's a model, it preserves some aspects of reality, but it cannot preserve all of the aspects of reality. That's impossible. That also means that there are multiple models of any one system that are possible, that we can construct. And the way we'll construct them depends on what is it that we want from those models. All right, so there are many different models. We just looked at the map, which is a spatial model of a system. You've learned so much, I bet, about regression, every archaeologist's favorite statistical technique. A regression is actually a statistical model, which you fit the data to. we already talked about ideas, how we create models of the past to explain it. Those are technical term for it is conceptual models. Like, oh, this is how I think the Romans were. And then today we're gonna talk about simulation, which is dynamic models that change over time. In particular, we're going to talk about my favorite technique, and it's also archaeologists' favorite technique, and I'll tell you later why. We're going to talk about agent-based modeling. Agent-based modeling consists of three main components: agents, we'll talk about them, the environment in which they live, and also time. Every simulation has a time arrow, so things change over time. And agent-based modeling is an exception here. So things will be changing over time. All right, so who are our agents? The simplest example that I can give you is, all of those SimCity games or, the Civilizations or World of Warcraft or whatever, where you have individual agents that are kind of individual software units, and they have attributes. So they can have age or energy or wealth or speed or location. They can have a preference for something. So those are those little people in your computer that are there and that have certain characteristics. So now when you think about it, if each agent has however many attributes, so they are male or female, they have certain age, they have certain energy, they have a certain location within the world, that means that the combination of those attributes could make them potentially unique within the population. So each of them can be different. And that also means that because they have those attributes, they can also change. And they can have rules of behavior that depend on their unique circumstances. So for example, if your age is 4, your energy is always high. And if your age is, say, 40, and you have a small little agent of the age 4 around you, then your energy is very low. If your location is in a city, then perhaps there is a certain set of behaviors that you do that are different than if your location is in the countryside. Or if you're a hunter-gatherer agent and your energy is low, then perhaps you're going to change your behavior and start investing in trying to get some food, right? So for each agent, depending who they are and what is their current situation, they may be behaving in a different way. All of those attributes, all of those characteristics, all of those rules of behaviors and how they change, all of that is defined by you, the modeler. You are the owner of this universe, and you decide whether an agent will be defined by their age or their energy or their socioeconomic status or any other thing, and what will be their rules of behavior in what circumstances. Agents in archaeology usually represent either individuals or households, depends on the scale that you work on, but they can actually represent many different things. They could represent cars or butterflies or countries or even planets. So, up to you. All of this definition of agents is so that we can model dynamics. So we can model processes, not just a static situation, but a process, especially social and socio-environmental processes. So as I talked, but this is super important, you see those are actually sheep, but they look like rhinos. So you have tons of those little animals here. And each of those, as we defined, as we said, have their own characteristics. One of them are their location. And that means that each of those agents will assess their situation in a way that is local, right? So this little animal will not necessarily know what happens with the animals here or here, but they will know whether they're like in a crowded environment. that means that they are bounded. This is a technical term, which means that there is no assumption. We do not assume that they have a full rationality, so that they will always behave in a fully rational way, and also that they have a global knowledge. So we don't assume that any agent will know, for example, what is the average crowdedness of this whole system. And that also means that their rules of behaviors may change during the course of the simulation. So, for example, if this gets overcrowded, they may start behaving in a different way that if their situation is different. And you know, when you think about it, I mean, that's how humans work, right? Like, you know, I live in Denmark, and I only know what the situation is kind of around me, right? Based on the information I have. I don't know what happens kind of globally in this country. I don't know the situation of every single person, or their, you know, decisions or their preferences, etc., etc. I don't always behave fully rationally, because I don't have all the information in the world. So I cannot always choose to behave in a way that is optimal. And I changed my behavior. For example, remember when COVID hit and we all stayed home, right? I mean, I don't normally just stay home and work from home, but things change, so our behavior changed. And this means that agent-based modeling is particularly good for modeling humans. And since we're in the business of archaeology, we mostly, you know, deal with humans. So it's perfect for us. All right, so why are we doing all of this? Because it sounds like a lot of effort. This is a dude that lived a long time ago. And he said that the whole is greater than the sum of its parts. And it's a bit of a mouthful, to be honest. But what it means is that very often you have systems where on the population level, on the kind of global level, the patterns of behavior looked very, very surprising and different than what you would predict if you just look at the elements of it. So, you know, economy is a very good example. We know that, for example, on stock exchange, there are people and they have one rule: buy low and sell high, right? Make profit. That's all that is behind it. There is no more than that. They just all want to make money. And yet it's really hard to predict stock exchange changes, right? I mean, if I could, then I wouldn't be sitting here. I would be on, you know, my yacht in Bahamas. And that happens very often in any social topics and anything related to humans, that, you know, you kind of know how humans behave more or less. But once they start behaving together, all of a sudden you have those population level patterns that are really unexpected. So modeling allows us to capture that, and it's called emergence, that process of translation of individual behaviors into global patterns that are not expected from those behaviors. It also allows us to do something that is very useful for us archaeologists, which is creating this in silico, so in a computer laboratory, for testing what if scenarios. So those kind of alternative worlds, like, let's see if Romans created more amphoras because they wanted to move more wine, then, you know, what would happen? And then you can build a model and figure it out, which is very useful because we cannot observe, you know, who we work on. I cannot go and say, okay, I'll just do some experiments with some Romans and then I'll see how they work, right? I mean, they're all gone. So there's no more in terms of observation science or experiments. Simulation allows you to do those experiments. And it's also important that it's process focused, because this is what we very often miss in archaeology. We would say, okay, well, there were more amphoras than cooking pots. Okay. Have we learned something about humans other than in that particular place people use more amphoras than cooking pots? Well, not really. So in order to kind of move up this hierarchy of knowledge, we need to look at processes. We need to look at how things changed and why they changed. And that's not easy. So that's why we need modeling. All right. This was all very abstract and high level. So I'm just going to give you an example now, which I hopefully will mean that, you know, it's a bit clearer. All right. The example is about Jerash, ancient Gerasa. It's a site. It's a Roman city in the Middle East. It's not particularly remarkable. I would say it's a mediocre Roman site in the Middle East. And it happens that our colleagues were studying and they came to us to do some data analysis and modeling. So let's go through the process and we will walk through that hierarchy that I talked about before. So first, there was a lot of data collection, excavation. People collected pottery, and there were tons of that pottery. So there were something like 700,000 pieces of pottery that were excavated in the project. What we then did is we turned that data into information. And the information was that almost, all you can have to see from those graphs is that everything's red, right? And the red just means that the pottery is local. And what we discovered from the data analysis once we turned data into information is that in Jerash, people used local pottery almost exclusively and for a very, very long time. So throughout the Roman period, throughout the kind of Roman early Byzantine period, throughout the whole of Byzantine period, throughout the Byzantine to early Islamic period, throughout the early Islamic period, they all used local pottery. And then finally, when the Middle Islamic period came, there was actually a hiatus in the occupation for quite a few years. So it's different people and then did not use that much local pottery. Still a lot, but not almost entirely. And we looked at different contexts and we could see that the local pottery was not just dominant, but just overwhelmingly dominant. We're talking 99%, which is crazy. We do expect local pottery to be the majority of pottery, obviously. That's normal that people use the pots that they create within the town. But there's just the disproportion of how much it was, that there wasn't even 10% of imported or regional pottery. That was quite surprising. So this is a information that we now have. People in Jerash used local pottery, almost exclusively. And the question is why? So we thought about different explanations for it. So those are our conceptual models of why people in Jerash use local pots for 800 years and did not use anything else. We thought, there is a possibility that there's just intrinsic value to those pots. Those pots are just better. They are better because they are cheaper, or they're nicer, or they're better quality, or they're better value for money. There's just something about those pots that makes them better. So that's one theory. Maybe that's why. We also, when you have a theory, you should create alternative. We had created a theory that perhaps they just preferred those pots. They wanted them because this is what other people had around them. All right, this is called conformist bias. So I want the same stuff as everyone has. Teenagers are great in that. They always want to look the same as others that are the same as them. But in general, we all have those tendencies that, we quite like things that people have around us. But there is also an alternative, that perhaps they had a preference for what no one else had. This is called anti-conformist bias. And you can think about it, for example, a lot of luxury goods, like those silly, handbags from Gucci, or, Lamborghinis, or whatever, those super expensive goods. People want them because nobody has them, right? They're special. And that's usually a very strong preference. And there could be other reasons why people used local pots. Perhaps other pots were introduced later, or perhaps the local pots were used more often, which means they would more often break, which means they would more often enter the archaeological record. And perhaps the local pots had specific functions that meant that they were more dominant. So we looked at all of those theories, and then we decided to model some of them. we focus on modeling the preference. So how would the world look like, and how would our archaeological record look like if people in Jerash had certain preference? So we created this population of agents, and they would interact with each other, they would talk, and the only thing that defined them was their preference for pottery. So they didn't have age, they didn't have wealth, they didn't even have location. All they had was a little head that thought, oh, I prefer pottery A, or I prefer pottery B, or I prefer pottery C. And they would interact with each other and discuss what pottery they prefer. It's a very boring society, but a model is a simplification. So we simplify the people of Jerash into little agents that only talk about the pottery and which one they prefer. So you can see each agent would have this kind of string of numbers when they say, oh, I like pottery A, I don't like pottery B, I don't like pottery C, and I don't like pottery D. But they could like two types of pottery. So this agent here, the pink one, likes pottery A and pottery C, but not B and D, right? And then when they talk to each other, they influence each other. So they talk, and for example, this little blue fella, they could talk to the pink one and say, oh, actually, if you like pottery C, then maybe I like pottery C as well. We created scenarios, which were the probability of preferring certain pottery. So we kind of modeled their heads. And those are different scenarios. A neutral, where everyone has the same probability of preferring any one of the potteries, but pottery types. A conformist one, where depending of what is the general population preference, people would also copy that preference. So if most people prefer pottery A, then you have a probability of the same proportion to prefer pottery A. Then we look at intrinsic value, where basically a type of pottery was just better. So that would be your probability of that preference. If pottery A is just 3 times better than B or C, then you have a 3 times more probability of preferring pottery A. And then we also look at the opposite of the conformist scenario, which is that the fewer people had something or had a preference, the more people would like it, right? So if only 20% people like pottery C, have pottery C, then we say, oh, you have a very good probability of wanting that. This is called anti-conformist bias. All right, and then, we can then model them talking to each other and see, if their preference translates into buying and using and discarding pots, then they create this archaeological record, and where, different types of pottery can have different curves over time, of pottery A being very interesting at the beginning, then dripping, and then actually gaining on popularity. So the results showed us that in general, when it comes to preference, people in Jerash would have to have a strong conformist bias, and there would have to be a very high intrinsic value to local pottery. So they would have to be either they really, really liked what other people had around them, or the local pottery would have to be really, really good for some reason, or a combination of those two. But the local pottery would have to be at least double as good as any other pottery, which sounds quite unlikely. What would not explain the distribution of pottery in Jerash is if people, if the local pottery was just slightly better than other types of pottery, then it wouldn't generate then we wouldn't see this pattern. And also, if the intrinsic value, so the being better, of non-local pottery was high, which we usually assume, then we would not expect to see the archaeological pattern that we see. All right, so this has been done, published. You can read the paper, and I will quickly. I will quickly go through a couple more cases, so that you see the kind of breadth of how you can use agent-based modeling in archaeology, not just by trying to figure out why people in Jerash were so boring in their choice of pottery. So a very common case, and one that you will be soon working on, is is modeling dispersals and migrations. This is a model that you will see very closely very soon of the first out of Africa dispersal in the Paleolithic, one of my favorite topics. And I showed it here because the model I discussed was aspatial. It didn't have a geographical space. This model is all about spatial distribution, and it basically tries to model how species-wide migration from Africa to the rest of the world could have happened 2 million years ago. There's, further on in the tutorials, there's another model, which is back to the pottery. I mean, we have too much pots in archaeology, which looked at production of pottery and how the distance from the production center should, manifest itself in archaeological data on different sites. So it basically created this world where pottery is produced and then sold on. And it creates different patterns of how much pottery they should be in different places over time. And then finally, there's a canonical model called artificial Anasazi about Puebloans, which are a community that lived in those incredible kind of cities cut in the slopes of a valley in the American Southwest. So, this is in Mesa Verde, so that's Colorado. But, Colorado, New Mexico, Arizona, those kind of areas. And this model created a simulation of people who lived in that valley, and they had their fields. They had maize, that was their main food, and they were farming maize. They were moving their houses from one place to another, creating families, having children, feeding them with maize. Those children would grow up and then create their own families, and they would have their own fields, etc., etc. And the simulation created a population. So it was possible to count from the simulation how many people there were in the landscape over time, and that was compared to historical data to basically figure out what drove the ups and downs in the population fluctuations among the ancient Puebloans in that area. And turns out it was predominantly environmental climate change. So just to sum up, superpowers of agent-based modeling. We've been talking about certain models, and this is all mathematics, right? I mean, at the end of the day, this is all actually equations. But I kind of hope that it was relatively easy to understand what I was saying, that it was, the entities I was discussing, the people in Jerash that prefer pottery, or ancient Puebloans that farm maize. Those are all familiar kind of concepts. It's much easier to model it than if I talked about, the lambda of the function, multiply to the e, whatever, right? So it's much easier to understand what's going on in the simulation than if we create the alternative, which is simulations are based on equations, mathematical equations. At the same time, ABM allows us to capture emergent phenomena. So it allows us to understand global level patterns that are emerging from the interactions among the components of the system. So people have preference for pottery and buy and sell and discuss with each other what they prefer. And at the end of it, you have the archaeological record of the number of pots. It also, compared to other simulation techniques, help us weakening the standard kind of assumptions that usually go into simulations, the full rationality and global knowledge, which is very typical of economic models. And also it allows us to model those things that are very important when modeling humans, which is communication, the fact we interact with each other, adaptation, the fact that we change how we behave depending on the circumstances, and also like long-term evolution of societies. And finally, there's this element that I find very important. It's not scientifically very important, but I think it's very important for us, people who study those systems, that agent-based modeling has this individual agency at the heart of it. So we're not modeling humans as if they were particles of gas. We're modeling humans in a way that allows us to capture the fact that each of them is unique, that each of them has certain characteristics, certain situations, that they live in the local situation and not, in a kind of artificial global stage. It really, allows us to model humans the way we like to, think about ourselves. And that's quite useful when we deal with humanities subjects. So, why should we do agent-based modeling? Well, first of all, it's cool to know why things happen and not just that they did happen, right? But the reason why we would like to know why things happen is that, we are, as I said before, in a pretty critical junction in history. It's a dumpster fire what's happening around us, right? And, Winston Churchill very famously said, history is simply one dumb thing after another. I think we have a responsibility as archaeologists to make sure that history is not simply one dumb thing after another, that it's actually something that we can learn from because we understand what happened, why people behaved in a certain way, and what were the results of that, so that if we were, it's really funny that it was The Onion that actually put it so nicely in. If we were to do something, then we perhaps should look whether doing the same thing in the past led to good or bad outcomes and under what circumstances. And in that respect, archaeology has a very strong position because we have access to the biggest comparative material about human strategies, human decisions in the face of crisis in existence. Like nobody else has such immense amount of data about what worked and what didn't work than we do. And I think we should be using it. So I, nudge you all to never stop at the level of data, because nobody wants to look at your Excel file. Not stop at the level of information. It's very good to do the data analysis, data analysis is important, but to go up to the level of knowledge so that together, as a discipline, and maybe we'll get our friends from social sciences and history and all of the social sciences and humanities together, we can get to the level of wisdom that would allow us to actually make decisions nowadays that are well informed. And with that, I will say there's a book. You can learn it all. This is the book. It's called Agent-Based Modeling for Archaeology. It was authored by two of the best agent-based modelers in archaeology, Colin and Stephanie, and I also helped a little bit. And you can download the book completely for free. Please don't buy it. Just download it from the publisher's website. It's published by Santa Fe Institute Press, and if you just Google agent-based for archaeology, this will come up as probably the first thing. But I will stop now for questions, and then I have some practical stuff. All right, so I'll stop sharing.
Thank you, Isa, for this great lecture and very inspirational as well. So first, maybe some questions from the audience. Okay, we have Alexander. Please.
Oh, thank you very much for so great and so inspiring talk. May I ask you to get back to the slide with the probabilities for neutrality and transmission biases for a minute, please? Just wanted to check a few details with you.
Yep. Yes, here we go.
So unbiased transmission, you have this equal probabilities for everything to be copied. So you mean you used individual learning model with kind of attached to stochastic network growth? So how did it work? Yeah. Thank you.
So basically, this just meant that when people were interacting, and say there's an agent and they have a preference for A but not B and C, you have the same probability of copying any one of those preferences. So the other agent interacting with agent A would have the same probability of copying A or B or C. Which is, compare it with the frequency conformist. So if the population had an already existing preference for A, and that could change dynamically over time, then the probability of copying that preference would be higher. So it's basically a probability of copying a preference from one agent to another, which then translates into, also higher probability of just, having the preference for that particular type. So visual learning didn't. Yeah, we had a little. We had a little individual learning kind of element. So I think there was, you usually code it as a mutation probability. So there was some very small mutation probability, but it didn't change the results. We did the sensitivity analysis on it.
I just wanted to check which of two modes, individual learning or random copying, you used for neutrality.
Yeah. So this was totally social learning in the results we present, because when we did individual learning, it just made no difference to the results. So we don't present those results, but I'm pretty sure that it's hidden quite deeply in the supplementary information.
And the other question is, could you please now return to the data slide, the very beginning with this proportions? I'm not a great fan of these endless terminological discussions, but I think it might be a bit confusing in terms of the information as it is understood in information theory. So basically, we're looking at proportions, not at entropies as diversity index or diversity measures.
Yes.
Maybe it would be reasonable to kind of bring the two together in terms of terms.
No, I totally agree, and I can show you the same graph with the sizes. So we show it as proportions, so that this is 100%, because in total there's 700,000 pieces of pottery, and they're relatively well distributed across the time periods and the different archaeological context. So it's not that the Romans were only 5 pieces of pottery. No. We're talking tens of thousands for each of those columns. So I do have a picture of it with the actual quantities, and I guarantee it looks very, very similar. There's fewer early Islamic pots and Middle Islamic pots, because they just didn't hit that many contexts with them. But all the way. Yeah. Early Islamic, there was quite a lot. Sorry. So early Islamic, Middle Islamic, and Middle Islamic contexts, there were fewer, but all of those, we're talking tens of thousands of pieces of pottery, and they're almost 100% local.
Oh, I'm sorry. Perhaps I was just not clear enough. Just in terms of information, is a term used? You are supposed to look at something like PI log PI or whatever entropy index you use.
No, we just
but
count.
Proportion is something different.
Yeah. This is everyone that did the data analysis course. This is the perfect scenario. All we had to do is just count. Just say, okay, 23,572 local. We did not calculate anything more beyond just literally the sum of pottery of a given type. There's nothing more to this than that. So we did not calculate, any other indices. I mean, we did, but a different study. For this, it's genuinely how many pieces of this pot do we have? This many. What percentage of all of the pieces that are dated to this particular period are those? Well, close to 99%. That's all we've done.
Thank you very much.
Just one comment is that I said this in the previous lecture, but I think today it's even more evident, is that you just see how much effort is being put into the preparation of the data, preparation of the simulation, and I think is really the strongest point of why using this and why using data analysis, is that you can make models, like hypothetical models in your mind, and then put it some in your paper, but this requires you to be very precise enough to translate it into numbers, to translate it into some equations and or probabilities. So you cannot just assume. You need to put some estimation and prove it somehow. And then, of course, you will have some results and you can interpret them. But I think, to my mind, this is one of the most important parts, is that you just learn to do this archaeology and science a little different way. Yeah, I think this is a good example of this. I probably have also another question.
I just want to follow up on what Alisa said. You know, when we first came to the project, the archaeologists said, oh, you know, we mostly have local pottery. And we're like, what do you mean by mostly? Like, what is it? Like, I mean, all sites have mostly local pottery. That's logical. And they said, yeah, I think we have more than it's normal. And I'm like, what is normal? Right?
Yes.
And they said,
Yeah.
well, we think we have more local pottery than other sites. And I'm like, okay, which other sites? How much more do you have? How much the other sites have? Yeah, right? So this is what Alisa is talking about. It's not enough to say we have predominantly local pottery. That's not okay. I mean, it's true. You've seen the graphs, but in order to actually be able to say something about it, we need to know how much more. We have to measure it, and how it compares to other sites. We did that as well. We do have more in Dirash of local pottery than other sites. But you know, we came across exactly this problem that you've described. That other sites would just say, "Oh, it's predominantly local pottery," and we're like, predominantly is what, 60% or 99%? Because that's a big difference. Both of, you know, so using those verbal terms, those words like, oh, it's quick, it was faster, or it was bigger, or we have predominantly, or it seems that this happened. It's not enough, because that doesn't allow us to be precise and actually say something concrete. So yeah, it's the data analysis. You cannot skip that stage on the hierarchy.
And also, it is probably more convenient later for someone, for example, to reuse your data, or to check your hypothesis, because it's of course also often skipped, but very important in archaeology. Yep. Is the opportunity to work with the same hypothesis, with the same data, once again, for other researchers. So the question is so if someone wants to do agent-based modeling, what are the prerequisites? Do you need to know a lot of math and learn some calculus, or start computer science from scratch, or where should you start?
All right. I mean, this is a nice segment into what I would like to do next. So I have to be clear about it. Some basic knowledge of maths that would not go beyond high school is necessary. So you should be able to add up numbers. So, you know, up to 700,000, it turns out. But, you know, it's not beyond us to do plus minus multiplication, division. You do not need to know calculus. It is useful, but usually we just collaborate with people that are better at it. It is not necessary to know computer science, or it is necessary to learn to code in a very specific language, which is not as hard as it sounds. But it's very, very far from being a computer scientist. And the reason why we use agent-based modeling in archaeology, you know, the model I presented you, this could have been an equation. Don't tell anyone I said it. This totally could have been an equation. And in fact, it would be more scientifically robust if it was an equation. But then, you know, I would have to sit here for like 3 hours and talk through these equations and go, and nobody would understand, and nobody would engage with it. And in the end, what is the point of doing it if nobody then reads your study and you know, learns more about the Romans, right? So we often use our agent-based modeling only because we cannot do maths. That's the sad truth of it. Is this being recorded? Yeah, this is being recorded. Well, there we go. There we go. The cards are open. But this is fine. This is still better than just saying, oh, you know, in Jerash, I think, you know, there was predominantly use of local pottery. And I think this is because people just like that pottery, the end of the analysis. So using agent-based modeling, there's nothing wrong about using that. And there's nothing wrong about not using equations. And one does not need strong mathematics skills or even strong programming skills to do that. In fact, there are so many models already created that with very basic skills plus some ChatGPT, you can create your agent-based model. You know, I just change the model that already exists to whatever you need to do in a matter of, you know, a week. So it's completely within our scope. It just feels very daunting when you are to start. So I have prepared a few resources to show to you, and I can also hang out for some more time if that's useful. And I will share that in a second. But is there anyone else who has any questions?
Just a second. Якщо у когось є питання українською, але не знаєте, як сформулювати англійською, то я можу перекласти. Тому сподіваюся, що будуть. Well, maybe there will be something later.
Sure, anytime. Do we need to do a break? I mean, are people like dying, staring at the screen?
I don't know. Well, last time we just decided that we will go in one.
Okay, let's push through,
so,
and you know, I will not be
least,
talking, so you can take breaks anytime, right? I mean,
yes.
Okay, let me share my screen again. Okay.
And we really have time. So we have at least 1 hour of scheduled lecture. So
fantastic. So I would like to spend this hour on people actually getting into ABM, because I think, you know, there's one thing about talking and all fun and games, but when it comes to it, once you start doing it, it's way more fun. So I would like everyone to start with a little tutorial that a colleague of mine prepared, which is called Seeing ABM. And you can either just Google it or find that link. And if you could spend about 20 minutes, 25 minutes on it, and then this is a general ABM tutorial, and then we'll jump into specific archaeology ABM tutorial later on. And I will be around doing my emails. So you can ask me any questions, or if you have any doubts, or if you have any problems, you can just basically ask me straight away. So there we go. Follow the link or Google it. Okay, let me stop sharing, and I'll put the link. Well, hopefully the link works.
Yeah, it works.
Yep.
I will put it into the chat, but I know that not everyone has an access. But
yeah. All right. So I'm here. If anyone needs anything, just ask me a question, and I will come back in 20 minutes.
Аріна, я думаю, що насправді ми можемо цю частинку закінчити запис, бо там буде велике 20 хвилин нашого
Окей.
роздивляння в екран.
Окей. Да, добре.